Okay, so in our lecture 4, data structures and algorithms, lecture 4, we are going to discuss computational complexity analysis. So what is this? So in this, so this is one of the most important parts of data structures and algorithms. I mean, the knowledge that you are getting here would be used, I mean, in all aspects from here, right? Like especially in this module, like the knowledge that you are taken from here would be tested. And then in next semester, so we will be using this knowledge. Then if you are going to do, sorry, if you are going to do programming in future, so most of you would do that. So in all those cases, the knowledge you are taken here would be essential, right? So that means like without that, there's no future, right? So if you are a program, so that much important, right? So I don't know, let's see yeah, so there are about 49 students, 2/3 is here, but I don't know, I would expect others would join at least later. Like if your friends are not here, just message them. This is important and to join the session. Okay, so computational complexity analysis. What is this? So in this, we are going to ask these questions, right? So in computer programming, there are several questions are raised frequently when working with algorithms. So we have some of these questions, and here we are going to find answers to these questions, right? So what are these questions? So these are some, but like there could be more questions related to this. So one question, right? When we are working with algorithms or data structures, so one question that could be raised is how much time does this algorithm need to finish? So how much time it takes to complete this algorithm? Sorry. So that means how long it takes for this algorithm to run. So how much space does this algorithm need for its computation? So how much memory it takes? How much space it takes in the memory for the computations? So for example, like in an algorithm, if we use an array, so then it takes the size of that array that we are using in the memory. And apart from that, if there are variables that we are using in that algorithm, so for those variables, it takes memory. So altogether, how much memory it takes? Memory එක කොච්චර ඕනද? So basically, like when we are downloading or when we are installing a software in our computer, we consider how much memory it takes. Right? Memory කොච්චර කනවද? මේ program එක memory කොච්චර කනවද? අපි ඒක සාමාන්‍යයෙන් බලනවානේ. සමහරලාට මේ අපි මේ සමහර දැන් browser එකක් අපි පාවිච්චි කරද්දී මේ browser එකේ memory එක පාවිච්චි කරනවා වැඩි. ඒ හින්දා අපි මේ browser එක පාවිච්චි කරනවා. අන්න ඒ වගේ අපි තියනවානේ මේ අපේ preference නේද? මේ අන්න ඒක තමයි මේ අහන්නේ. කියන්නේ මොකක් හරි algorithm එකකදී කොච්චර memory එක පාවිච්චි කරනවා. memory එක ගොඩක් යනවා නම් ඒ algorithm එක අපි alternative එකක් තියෙනවා නම් බලනවා. Right? When it takes a lot of memory, then we are trying to find an alternative for that algorithm. Right? So even for the time, so if it is very slow, if the algorithm is very slow, then we are always trying to find some alternatives, better alternatives, like for this one, for that algorithm. Okay, so how much time it takes, how much memory it takes, and then how this algorithm is faster than other algorithms, right? So then this is again important. How can we compare two algorithms, right? Whether this one is faster than that one. So how to do that? So which is the best algorithm to perform this task among several candidate algorithms? If we have several algorithms, we have to choose the best algorithm based on the performance or the memory, whatever, right? Based on these questions. In this lesson, so we are going to find answers for these questions. How to do that? So that's why it is important. If you're a programmer, definitely when you're doing when you're doing the programming, so you have to compare algorithms. You have to compare two programs. You have to compare data structures. You have to choose one among several candidate data structures or algorithms. So at that point, you have to have a proper understanding on these concepts that we are going to learn here. Then definitely, if you are going to an interview, right? For internship, sometimes you won't get questions from here, but so sometimes, like in some cases, you will get questions. But if you are going to a job as a programmer, software engineer, definitely you'll be getting questions from him, right? So these concepts would be haunting. So the rest of your life. So that's how I could put it, right? Okay, right. So let's see what we are going to discuss here. Complexity analysis. So in complexity analysis, how efficient an algorithm or piece of code. It could be algorithm or just a program or a part of program. It's a piece of code. How efficient it is. So efficiency covers a lot of resources, including CPU time, memory, disk usage, network usage, right? How efficient is an algorithm, right? This efficiency covers many aspects, right? Efficiency කියලා කිව්වහම ඒකට CPU usage. So that means the time. So then memory, like RAM, right? So then disk usage. So when if you are using the disk, how much it takes. The සමහර programs තියෙනවා ඒවා මේ RAM එක වැඩි use කරන්නේ නැහැ. හැබැයි disk space එක use කරනවා. ඒ කියන්නේ අපි දැන් ඒක install කරනවා නම් සමහර programs අපිට මේ hard එකේ ඉඩ තියෙනවා. hard drive එක. Right? We need a lot of space in the hard drive. In some cases. Right? The network usage. If network is used, then how it is used. Now, so for example, like in our university, we have a examination management system, right? Still, it is in progress. I mean, we are using that to release your results. We are using that system. In that system, like a person, in my opinion, the network usage is very, very bad. But I mean, its original architecture was supposed to be in one. For example, like if it is in faculty, so we have a server in our faculty and we can use that. But currently we are apart from the main university, so we don't have our own server here. So we are using the main university server. So we have to use a network a lot. So because of that, that system is, I mean, using that is terrible. Sometimes entering just one result, sometimes we have to wait a long time because of the network delay. Right? Network usage is very, very important. If it is relevant, right? මේ වගේ කියන්නේ network usage කියන එකත් සමහරලාට බොහොම වැදගත් වෙන්න පුළුවන් මේ සමහර applications වලදී. So in that system that I am talking, so the other things are really, really good. I mean, CPU usage, I didn't care much, but for example, RAM and then disk usage, those are fine, no problem. But network usage, so there's a problem. So actually, we all are aware, and the developer is also aware. But like, so he's going to do some changes, and then the architecture would be changed, and so it will be fine. But currently, we have that. Right? Okay, so these things are to be considered, right? However, in our case, like at this point, so we mainly consider the time, right? So we have, like, for example, time complexity or memory or space complexity, right? So mainly these two are considered, and then here we consider mainly time, right? Right, okay. So analyzing algorithm. So how to analyze algorithm? That's what we do here, right? Complexity analysis means, the complexity means we are measuring the goodness of an algorithm and a data structure. Basically, we are measuring the goodness of a program, algorithm, data structure. So data structure means, so with data structures, operations are involved, different operations are involved. So the goodness of those operations. Right? So characterizing the running times of algorithms and data structure operations. So here the goodness, we measure the goodness by characterizing the running times of algorithms and data structures. Right? Again, make it then running time. Run when the kochchara velawak yanawa කියන එක බලන එක තමයි අපි mainly මෙතන කරන්නේ. Space එක දැන් මෙතන මම කිව්වා මේ memory එක කොච්චර යනවද කියලා වැදගත්, disk එක වැදගත්, network usage එක වැදගත්. හැබැයි මෙතනදී අපි mainly මේවා සලකන්නේ ඊට වඩා අපි generally even in like in generally when we are considering when we are analyzing, we are measuring the goodness of algorithms. The time is the most important. Right? Others are important in some cases, but generally, time is the main consideration. If we can do something faster, yeah, that would be better. Because, like, for example, memory usage. So, memory usage is not a big deal. In the current computing world. So because like if you don't have enough RAM, so you can add an additional RAM, right? Then the memory එක ගොඩක් යනවා නම් memory එක මදි වගේ නම් තව RAM එකක් දාගත්තාම හරියයි. තව RAM එක මේ වැඩි කරා නම් හරියයි. So you can expand the RAM. It is possible. Even in disk, so if disk is not enough, so you can find a bigger hard disk. Right? That's fine. So even network, like the network bandwidth is not enough, so you can go for another like different connection, so better connection. So for these we can provide solution easily, right? But the time actually, so this is important. Like physically there are things that we can do, but not easy as this, right? ගැන අපිට ගන්න පුළුවන් හොඳ මේ fast processor එකක්. හරි? ඊට වඩා efficient processor එකක් ගන්න පුළුවන්. ඒතකොට හැබැයි දැන් processor එක ගන්නවට වඩා අපිට lazy මේවා වෙනස් කරන එක lazy ඊට වඩා processor එක. processor එක මාරු කරනවා කියන්නේ කෙලිම මේ again computer අලුත් computer එකක් ගත්තා වගේ නේ අතට. right? එයින්ද අපි දැන් මෙතනදී mainly අපි time එක සලකනවා. right? the memory කියන එක එච්චර ලොකු දෙයක් නෙවෙයි අද කාලේ. memory එක වැඩිපුර යනවා කියන එක so if we take the updates or the new versions of the software, like most of them are using a lot of memory. They don't care about this memory complexity, right? Because they know now we have the higher RAM are available, right? Disk space are available. That's right. That's not a problem. So here we consider time, mainly time. Running time of an algorithm or data structure operation increases with input size. Okay, so this is important. Huh? The running time of an algorithm or data structure operations increases with input size. What is this input size? Although it may also vary for different inputs, all of the same size, right? Input size or different inputs of the same size. So for example, if we take our array and then okay, so if we have an array of small array, right? Suppose the size of this array is 10. Size of the second array, right, is, suppose it is 10,000. So if we search in the first array, array number 1, and if we search in the array number 2, usually, like by like in general knowledge, we could say this array would take less time than the second array. This array would be faster. This is faster. Right. So the input size, right, running time increases with the input size. Input size is very running time is very. That's general knowledge. Although it may also, right, vary for different inputs of the same size. That what is that? Right? Suppose if we have an array with the same size, right? So suppose this third array, right, number 3 array, it is the same size as the number 2, 10,000 items, right? But the data in this array is different from the data in the second array. Arrays දෙකේ තියෙන data වෙනස් වෙනවා. Suppose we are doing like sorting. If we take sorting, right? So we have an array. Right. So we are, suppose we are going to, the size is the same, right? 10,000. This one, 10,000. Right. So we are going to sort them in ascending order, right? Okay, the first array, this array, right? The number 2 array, number 1 array. Suppose the largest value is here. Sorry, smallest value is here. Suppose the smallest value is here. The second smallest value is here, right? So likewise, the largest value is here. Suppose it is 25,000, right? Suppose the value here is 25,000. Suppose that's the largest value. So the first array, you can see it is in the opposite order. actually we need 2 to be in here and 8 to be here and so on. Again, තියෙන්න ඕනේ විදිහට නෙමෙයි සම්පූර්ණ අනිත් පැත්තට තියෙන්නේ. So array is in descending order. So we have to totally make it over to convert it into ascending order. මේ descending order එකට තියෙන එක ascending order කරන්නේ. ඒතකොට මේ හැම item එකම සම්පූර්ණයෙන් වෙනස් කරන්නේ. So original array is in the opposite order, right? Suppose the second array, right? Second array would be, it is in, like naturally it is in the order, right? That we are expecting. දැන් array එක හිතන්න අපි දැන් ගත්ත random array එක already ඒක මේ sort වෙලා නම් තියෙන්නේ. ඒ කියන්නේ අපි හිතලා කරපු එකක් නෙවෙයි, already ඒක ඉබේම sort මේ කියන්නේ මේ හදද්දිම ඒක මේ randomly අපි generate කරා කියන්නේ. ඒතකොට sort වෙලා තියෙනවා. It could happen, right? So in this case we don't have to do anything here. We are just checking. We don't have to change any values here when we are using our sorting algorithm. So time it takes for this array, right, would be very less. Time it takes for this one would be it would be the worst, right? So for example, this is the worst case. We call worst case. This would be the best case. The size is the same, but so based on the values that we have, right, the time it takes would be different, right? The පළවෙනි එකේදී අපිට මොකුත්ම කරන්න දෙයක් නැහැ, සම්පූර්ණයෙන් වෙනස් කරන්න ඕනේ. ඒ කියන්නේ තියෙන order එක නෙවෙයි, ඒකේ විරුද්ධ order එක හදන්න ඕනේ. ඒතකොට හැම value එකක්ම change කරන්න ඕනේ position. Most probably එකක් සමහරට මැද තියෙන එක වෙනස් වෙන්න ඕනේ නැති වෙයි. ඒ අරින්න අනිත් ඔක්කොම කෙලිම දැන් මේ දෙක තියෙන එක මේ ළඟ පාතකට නෙවෙයි යන්න ඕනේ. ඒක යන්න ඕනේ ඊට මේ 9999ක් කලින් තියෙන position එකට. So even the values that we are changing, they have to change. They have to move to a long distance, right? So long distance changes are there a lot, right? So here, the second one, we don't have to change anything. I mean, we don't know it is already sorted, right? We don't know that. No, so it is a random array. If it is a random array, so then what we have to do is we have to just check. So if you put this array into your algorithm, right? Your algorithm of one of your sorting algorithm, so then it will check. They will check, but the values won't be changed in most of the cases because values are in order, right? Nothing to be changed. Check කරන්න අර මේ compare කරන ඒ steps වලට විතරක් time එකක් යයි. හැබැයි මේ මොකුත් මේ අර shift කරන්න swap කරන්න ඕනේ. No swapping, no shifting, nothing. Just comparison is there. So what I wanted to say here is, right, same size, different inputs of the same size, it will take different times, right? So in this case, actually this would be, we call worst case. වෙන්න පුළුවන් නරකම දේ. අපි මොකක් හරි order එකකට හදන්න ඕනේ. ඒකේ විරුද්ධ order එකකට තිබ්බොත් තමයි ඒක වෙන්න පුළුවන් අපේ නරකම input එක. So that's a worst case. The best case is it is already in order that we are expecting. There's nothing to be done. So that's the best case, right? In most of our general examples would be in between these two. The worst case එකයි best case එකයි අතර තමයි ගොඩක් වෙලාවට අපි ගන්න some general random inputs තියෙන්නේ. Right? Even the size is the same, the time it takes, right, would be different for different, right? If we take different inputs, right? So if we have different input, right? Suppose we have this input, right? One input, it takes this time, this much time. If we take different input, the same size, different input, right? So take different time. So likewise, the worst case would be this one. The best case would be this one. This one would be the best case. This one would be the worst case. All the other inputs would be in between these two. යන time එක මේ දෙක අතර තියෙනවා. ගොඩක් වෙලා. So here the time it takes time. Right. So also the running time is affected by the hardware environment. Yeah, again, this is important. The running time, okay, so we are running those algorithms, right? So based on our hardware environment, the processor, clock rate, memory, disk, all those things together. So based on the hardware environment, it would be different. And software environment. So the operating system that we are using, the programming language that we are using, in some cases, those would be affected. Software environment in deciding the time in which algorithm is implemented and executed. Software environment in which the algorithm is implemented and executed. Hardware සහ software අනුව අපේ algorithm එකට යන time එක වෙනස් වෙනවා. සමහරලාට දැන් so for example, like so when I was working, so one of my friends was working on an algorithm. It's a new algorithm. So it is related to, as I remember, like 3D modeling. 3D modeling, like taking a video, for example. So I am moving in this room and I'm taking a video. And then, right, so when I am playing that, so based on that video, so I need to create a 3D model of this room, 3D model, right? So I have a video, right? So I have a video here, right? So that video is playing, like taken in one place. So based on this video, 3D model of this area has to be created. 3D model. 3D model එකක් create කරන්න ඕනේ මේ video එක. අන්න ඒ වගේ වැඩක් දැන් කරේ. Right? Like so he used a new algorithm. So one of our professors created that algorithm, and actually my friend was given the task to implement it and then make a prototype. The algorithm අපි මොකක් හරි අලුත් algorithm එකක් හදලා අපි ඒක මේ implement කරලා බලනවා. So we implement that algorithm and we create a prototype. මේ මේක මේ proof of concept prototype is created. මේ algorithm එක හරියනවාද කොයි වගේද වැඩ කරනවාද කියලා පෙන්නන්න අපි පොඩි හදනවා මේ ඒක implement කරලා පෙන්නන්න. Right? So my friend was given that task to implement that. It was so time consuming, right? So it took like usually it takes a long time, right? So then that professor who was involved in that project, so he had money, right? Like he had money, so he bought a new computer for my friend, right? So it is a Apple computer. I don't remember the name of that machine. It is like the CPU is something like this, like a disk, right? I don't remember the name. So if you search, so you will find it. So it was so powerful computer. Right? So the most powerful computer I have seen. I mean, I have worked with. I have seen powerful computers, but like in this computer, like I had a chance to work with my friend. So in this computer, like for example, previously in his computer, his previous computer, it takes one night to run that program. For example, like one night means like in the evening when we are leaving the office, so he start running it, like so he put it to be executed, and then the next morning, so sometimes even next morning it is running. So especially like if you have done, I don't know whether you have worked with neural networks, and especially with the deep neural networks, right? Sometimes it takes days, weeks to train one neural network model, right? So for example, like last year, I was doing a lot of experiments with deep neural networks. I mean, it takes days. Right? Like I have to kept this computer for days, right? Reserved for just running that program, right? So now actually I want to do, I want to continue those experiments, but I cannot do that at this moment because now I only have this computer, right? I don't have extra computer at home. So if I use that for running my things like those training, so then I cannot do any lectures or anything else, right? So that's, so it takes a time, like in that case it took a long time, but with that new computer it took just 5 minutes. 5 minutes. I mean, I was so surprised actually, right? Again, then there අපි පැය ගානක් තිස්සේ රන් කරන එක දැන් රැට තමයි රන් කරන්න දාලා යන්නේ, උදේ වෙද්දි තමයි උන රන් වෙලා තියෙන්නේ. ඒතර ඒක විනාඩි 5න් විතර මේකේ රන් වෙනවා මේ අලුත් මැෂින්. Right? So hardware has a big impact on the time, right? The new computer, it was very expensive, right? Like it's not affordable for general users. So that was a special project. So the professor had a lot of money, so he bought that for my friend. So it would be very convenient working with that computer, but very expensive, right? So hardware environment has impact. It has an impact on the time. Hardware and software environment as well. Right? So when we are analyzing algorithms, we have to think all these things, right? The input size, different inputs of the same size, and then the hardware environment, software environment, right? So the thing that you have to understand is, right? So you cannot say, like if you are running the same algorithm in two different computers, right? So this is old computer, this is new computer, right? It takes hours, 5 hours, for example, here, and it takes 5 minutes in this computer. So in that case, we cannot say, so this algorithm is fast, right? Suppose if you are running two different algorithms, one algorithm is executed here in an old computer, the other algorithm is executed in very powerful computer. It takes 5 hours for this one, and it takes 5 minutes here. So we cannot say, so algorithm 1 and algorithm 2. So algorithm 2 is faster because the hardware environment are different. If you want to compare two algorithms, what you have to do is you have to run them in the same environment, right? Same environment, same similar environment. If you can use the same computer with the same situation, so then you can compare. So when we are comparing, you have to think about these things. Okay. So even if you have the same environment, right? So if you use different inputs, right? Suppose if you are giving an array for the algorithm, right? So if you are giving two different arrays, the times would be different. يعني පළවෙනි එකට අපි දෙනවා එක array එකක්, දෙවෙනි එකට දෙනවා array වෙන different array එකක්. එතකොට එහෙම වුණොත් එහෙම එක different array කියන්නේ size එක different වෙන්න පුළුවන්. ඒකේ තියෙන data different. Then we cannot compare them properly. ඒ කියන්නේ මේකෙන් එන time එක අපි බැලුවොත් එහෙම මේකේ අඩු වුණොත් මේකේ වැඩි වුණොත් ඒක හරියටම ගන්න බෑ මොකද මේ inputs වෙනස්. So we have to give the same input in the same environment, hardware, software environment, then we can compare. Then only we can compare. Right? Okay. So how to compare these algorithms? How to compare these algorithms? How to compare? So we are going to discuss 3 approaches. 1, 2, 3. The first one is experiments, experimental analysis. Right? Experimental studies. This is an effective method to study the efficiency of an algorithm. Right? In this technique, the actual algorithm is implemented. This is important. Huh? We have to implement the algorithm first. So if you are going to compare 5 algorithms, then you have to implement those 5 algorithms first. Right? And experiments are conducted on it by running the program on various test inputs. So if we just take one algorithm, so you have to run that algorithm, implemented algorithm with different test inputs. So we give different inputs and we have to check. Then the time is recorded. We have to record the time. We have to measure the time for each execution, and the comparisons can be performed on those recorded times. So also do the same to other algorithms. Like algorithm gatta, eka run kara එක test inputs වලට time එක manna. So we measure the time. So similarly, we do that for all algorithms which are to be compared. Right? So here, like, so when we see marathon, we do that. We do that. We do similar thing. So we provide the same, like, so if we take like 2 runners, right? 2 runners. So they are running. So one is running, right? So one is running in Sri Lanka. So where? Sri Lanka where? So let's say Nuwara. Right? So there are a lot of mountains. So one is running in Africa. So any for example, Sahara Desert, right? So one is running there. Right? So another one is running somewhere else. Right? So we measure time here, right? And then we measure time here and we measure time here, right? In 3 places, right? Can we compare it? Can we say this one is the best runner? We cannot do that because the environment they are running is different, right? මෙයා මෙන්න මෙතන මෙන්න මේ දැන් නුවරඑළිය ගත්තොත් එහෙම මේ කඳු තියෙනවා හැබැයි මේ කඳු ඒ කියන්නේ මුහුදෙන් සෑහෙන මුහුදු මට්ටමින් උඩ, right? කඳු තියෙනවා හැබැයි මේ ටෙම්පරේචර් එක අඩුයි. දැන් අපි ගත්තොත් සහරා දැන් කාන්තාරේ දුවනවා කියලා එතකොට මේ මිනිස්සයාගේ මේ කියන්නේ ඒක මේ කඳු නැති නිකන් අපි පැතලි කාන්තාරයක් කියලා මේ ඒතර කඳු නැහැ හැබැයි ටෙම්පරේචර් එක වැඩි මේ ඒ එන්වයරන්මන්ට් එක මේ කලින් එකෙන් සම්පූර්ණයෙන් වෙනස්. ඊට පස්සේ මේ තුන්වෙනි තැන ඊටත් වඩා වෙනස්. හරි. එතකොට මේ වනිකම කළාම දැන් කොහොම හරි මේ තැන් තුනක දුවන. We cannot compare their times. What we have to do is, if we want to compare, we make 3 of them running in the same course, right? So we have to invite them to one place and we give them the same course, right? Like this, right? They are running the same course. So these people, so there are women here, right? Right? And then like the people from different areas with different backgrounds, right? So if you want to compare their running ability, so we have to let them run the same course in the same environment, like they have to do at the same time, right? දැන් මේ කෙනෙක් උදේ දුවලා අනිත් එක්කන හවස දුවලා එහෙමත් බෑ. එකම වෙලාවෙ එකම කන්ඩිෂන් එකේ යටතේ දුවන්න වෙනවා. So then we measure their ability, right? So experimental studies, we do that, right? So එකම machine එකේ එකම environment එකේ අපි algorithms run කරලා බලමු. Right? So in Java, so we have we can measure the time. So this method is available, current time millis, right? I don't know, well, with Java new versions, whether it is available. I created these notes like maybe 3 years back, right? So there could be some new methods available. So however, so this method can be used, right? So we can measure the time, right? Then what we have to do is, in a programming case, what we have to do is, so we have to, so when we write our algorithm, right? So before executing at this point, so we have to find the time, right? Time 1 or T1. At this point, the time is T1. Then at the end of the algorithm, so we have to measure the time, T2. Right? So then the time that was taken to execute this algorithm would be T2 minus T1, right? So we call elapsed time. Elapsed time of the algorithm can be calculated by using the difference of those two times. පටන් ගනිද්දි time එක මැන්න, ඉවර වෙද්දි time එක මැන්න, current time millis. So we can measure the time, right? T1, T2, we take the difference. So that's the time it takes, right? T2 minus T1 for the algorithm. Right. So in our program, so this is the starting point of the algorithm and this is the end point of the algorithm. So here, so before that, just before the starting, we get system.current time millis. Okay. The starting time here. And then just after the end, we take the current time millis. So that's the end time. So then elapsed time can be taken as this one, end time minus time. Right? Okay, so here, so I have given two methods. Actually, I have given these two methods to I don't remember your maybe one of your super senior batches. So I gave them these two methods, right? They do the same thing. If we take the first method, right? So it is the return type is string. So those are static methods. I'm not going to talk about that here. So the repeat 1 and repeat 2. Right? So they take two inputs. Two inputs are like character C, char, C, and then N, integer N. Right? This one the same. Right? Then what it does is it has a string here, string, and then empty string. Initial empty string is there, and then in a loop. So loop goes from 0 to N. N is the input here. Right? So N number of time this empty string is appended with this character. Right? This character is appended N times. Right? So that means so we have empty string, right? Empty string, right? Empty string. Suppose we input A as the character, right? And then a number of time N, right? 10, right? N කියලා අපි 10 දැම්මොත් character එක විදිහට A දැම්මොත් A කියන එක මෙන්න 10 පාරක් ඇපෙනවා. And 10 times A is appended in this empty array. මේ empty array එකට A එකක් දානවා දෙකක් දානවා ඒ විදිහට n වාර ගන්නත් මේක එකම append කරනවා. This is appending to the array. And then this array, so this string is return. String එක return. Right? In repeat 1, we do the same thing using string builder class. So this is general string. This is string builder. String builder. It is so we create a new string builder object. Usually it is an empty string, and then to that we append. So in a string builder class, so we have a method to append. We don't have to use this operator to append. We can just call append method. SP. So again, we append it n times. Right? The for loop is the same, but only difference is we are using string builder and this method. Again, we return this string builder and we convert it into a string. Right? So we do the same thing using two different methods. Then I ask your super seniors to change the n, size n. So first do that for 10. Do that for 100. Do that for 1000. Do that for 10,000. Use different n's and check the time. n එක වෙනුවට ගන්න n value එක මේ different values අරගෙන කරන්න කියලා මම කිව්වා experiment. What they had to do is they implement this here and then they check the time before and after and then find the elapsed time. Right? Actually, the result was something like this. Something like this. They measure the time in milliseconds. Right? So if we take very, very small n's, if n is very small, 10, 100, so the repeat one takes measurable milliseconds, but repeat 2, it takes just 1 millisecond, even up to 50,000. Right? And then, so up to 12 million inputs. Right? I asked them to do the experiment. Actually, most of them couldn't complete up to several millions. So you can see that here, right? So this is 2.8 milliseconds. That means like just like 2 seconds. But then 7 seconds, 39 seconds, right? It takes, as finally it takes a lot of time here. But repeat 2, it takes only 135 milliseconds. See the difference here? Size එක වැඩි වෙන වැඩියට මේ difference එක බලන්න. So if we take if we compare them, right, repeat 2 and repeat 1, repeat 2 is in a different level actually, if we compare these two. Right? So can you guess the difference here? Why it takes, why it shows that's that much difference? Again, I mean 12 million data today. Again, loop 12 million පාරක් යන්න මේකෙදි මෙච්චර time එකක් යන්නේ ඇයි? Right? මේකෙදි මෙච්චර එක අඩු වෙන්නේ නැහැ. So why so much difference? Yeah, Johan, so it is correct actually. So string builder has an internal buffer, so it won't make a new object every time. But string will make new object every time when loop is running. Yeah, so that's the reason actually. The reason is when once the string is implemented, like once the string is created, strings cannot be duplicated. Sorry, strings cannot be so the strings are arrays, not like we cannot change that, change the size is fixed, immutable. When we talk about arrays are immutable. Once array is created, that's the array. We cannot change the size. Then how we append? When appending, we create a new array. Every time we create a new string, and then we copy the items of the previous into that new string. ඒ කියන්නේ දැන් මෙතන මේ array එක මෙන්න මෙහෙමයි වෙන්නේ. Right? At the beginning, it is empty array, right? And then when we create, when we add a, right? So it is creating a new array, new object, as you said, right? Then we add a. මේ double quotes දාන්න එක array එකක් කියලා පෙන්නන්න. මුලින්ම empty array, right? So then we create step 2, we create a new array with size 1, and then we add a. And then third iteration, it will create a new array. Right? With 2 spaces. And then it will copy the previous ones. And then the newly added appending A is added. It could be any character that you are inputting here, right? Input karna මොකක් හරි character එකක්. දැන් A කියලා ගත්තොත් එහෙම. Yeah? So in the first step, like before appending, it has to create a new string with additional space, and then these are copied. Then newly A is added. So likewise, every time it creates new object, and then the previous values are copied, and newly inserted value, newly appending value is added at the end, right? So that's why it takes so much time. But in this case, string buffer, it has an internal mechanism, as Johan said. It has a buffer, like it does not just keep like size 0 or size 1. It already creates like a bigger string, right? It's an array, right? Like, so then it can add A. In the next case, it does not have to create a new one. It has empty space. Buffer is there. Likewise, it creates new it does not create new object every time. Right? Time to time it would do, but generally it does not have to create a new object. So that's why it takes string buffer. So see the difference. See the difference. So that's why, I mean, if I asked you to do something, so that's why you have to check whether you are doing it in the best way possible. මම මොකක් කරේ ඇල්ගොරිතම් එක ලියන්න කිව්වම දැන් ෆස්ට් ඉයර් එකේ නම් ඒක කොහොම ලිව්වත් මම ලකුණු දෙනවා. හැබැයි මේකෙදි නෑ. මේකෙදි දැන් මම කිව්වොත් එහෙම මේ ඇල්ගොරිතම් එක ඔයා ලියන්න ඕනේ ටයිම් එක අඩුයි. ඒකට කියන විදිහක් තියෙනවා. Right? So there's a way to say that, like you have to write this algorithm at this level. So then you have to write it as I told you. Right? Again, මොකක් හරි අහුවාම මේ ප්‍රෝග්‍රෑම් එක කොහොම හරි ලියන එක නෙවෙයි මෙතනින් එහාට වැදගත්. ඒකයි මෙතනදී අපි මේ කතා කරන්නේ. Right? So this experiment analysis. So like basically I told the reason for this difference. Somehow the experiment analysis is done like this. So we have to do experiments. We have done experiments and then we can compare. Okay. So based on that, we can say, okay, the repeat 2 algorithm is better. Right? We can clearly say that. See that. See? Okay. The problem here is, right? So there are several challenges. What are the challenges? So when I gave this task for your super seniors, they took like days to complete, right? In this case, these algorithms are simple, but if it is if we compare two complex algorithms, then implementing those things, first we have to implement them, both algorithms. Implementation takes time, right? මේක implement කරන්නම යනවා ලොකු time එකක් සමහරවිට. කෙනෙක් algorithm එකක් implement කරන්න අපි හිතමු මේ දැන් දවස් 3ක් විතර යනවා කියලා උදාහරණයක් විදිහට. එතකොට මේ දෙක implement කරන්නම සතියක් විතර. It takes 1 week to implement 2 algorithms. And then to do this experiment, it takes maybe another week or so. සති දෙකක් යනවා මොකක්ද හරියන ඇල්ගොරිතම් එක කියලා තෝරගන්න. එතකොට අපේ මේ project එකේ if in our project so if we have to compare several algorithms, then it will take months. It's a waste of time actually. I mean, these experimental studies, they are effective, but not, I mean, we can find which one is better, right? But it is not efficient. Experimental running times of 2 algorithms are difficult to directly compare, right? Unless the experiments are performed in the same hardware and software. So that's another problem. So if we do one experiment in one computer and another experiment in the other computer, it is not a good way to compare. It won't work, right? The other way is, the other thing is experiments can be done only on limited set of testing. Yeah, so that's the thing here, right? So here, N, 50,000, 100,000. I'm not checking 51,000, right? So there are many inputs between these, right? You can make few samples of inputs, right? But there are many other inputs. We don't know exactly what's happening in those inputs. In experimental analysis, we can do the experiments with the limited set of inputs. අපිට තෝරාගත්ත inputs කීපයක් එක්ක විතරයි comparison එක කරන්න වෙන්නේ. ඔක්කොම තියෙන ලෝකේ තියෙන පුළුවන් ඔක්කොම inputs අපිට check කරලා බලන්න වෙන්නේ නැහැ. Hence they leave about the running times of inputs not included in the experiment, and these inputs may be important. In this case, actually, I mean, generally we can see like, the inputs are higher, the time is growing, right? But in some cases, in some other cases, there could be inputs that we haven't tested would be very important. ඉතින් අපි ටෙස්ට් කරන ඉන්පුට්ස් ටික තියෙනවානේ. ඒ ඉන්පුට්ස් ටික නැතුව අර අපි ටෙස්ට් නොකරපු ඉන්පුට්ස් වල තියෙන්න පුළුවන් වැදගත් ඒවා. අන්න ඒවා මෙතනදී සලකන්නේ නැහැ. Right. So these are challenges, the second challenge. And the third challenge, the algorithm must be fully implemented. So we have to implement the algorithm. Right? Without implementing, we cannot just analyze. It is a waste of time. Waste of time and waste of resources. There should be a better way. Right? So what are the three challenges? So the hardware software environment should be the same. And then we cannot check all the inputs, all the possible inputs. And then the algorithm should be fully implemented. Right? So then, we need a better approach. How to compare experimental analysis. It is good, but we have to go beyond that, right? So the second one, go beyond, moving beyond experimental analysis. So there should be independent of the hardware and software environment. It should be independent of hardware software environment. So without considering hardware software, we have to compare. Without need for implementation. Without implementing, we have to, I mean, if we check, without implementing, that would be the best, right? If you don't have to worry about the hardware and software, that would be the best. Then consider all possible inputs. If we can consider all possible inputs, if this input is given, the algorithm would be like this. So if we can see that, so that would be best, right? So based on these challenges, if we can overcome those challenges in any mechanism, that would be the best. So we are going beyond experimental analysis. So then we are going for counting primitive operations, right? So counting primitive operations. So it is something like this, right? I think you have seen this, right? If there is a big there's a big crowd in a rally or in a sports event, right? If you want to measure, if you want to roughly measure how many people were there, right? So this is one method that which is used, right? So if we take a photo, right, instead of just counting people, instead of just counting each and every person, it is impossible actually. So we can just guess. We can just guess. So this is one method of doing it. So these squares, so we can roughly measure, like roughly have an idea of how many people in one square, right? So based on that, we can just have an estimation how many people are here. Right? Exactly. I mean, how to do this? I haven't done that actually, but there's a mechanism doing this. The මෙහෙම මේ කොට්ටු ඇඳලා මේ විදිහට කරන එහෙම mechanism එකක් තියෙනවා. Right? So in this case, actually, the second one, counting primitive operations. Primitive operations. Right? So here, what we do is, we count number of operations. What operation? Primitive operations. Primitive operation is an algorithm or program can be defined such as primitive operations in an algorithm can be defined as assigning a value to a variable, performing an arithmetic operation. For example, adding two numbers, comparing two numbers, like equal the kilobal, comparing two numbers, so comparing which one is larger, which one is smaller, or two values are equal, comparing. Accessing a single element of an array by index. Array index. Using array index, we access one value. Right? Calling a method. Right? Returning from a method. These type of operations. Right? Assign කරන එක. Variable එකකට assign කරන. ඊට පස්සේ මොකරි arithmetic operation එකක් කරන්නේ. Comparing two values. Accessing a value in an array. Like these are primitive operations. There are many other, like these are some examples of primitive operations. So primitive operations means, so that operation is done and then we cannot divide that operation into other mini operations, right? So if we take, let's go to one algorithm here, right? If we take this loop, for example. So in this loop, there are several steps: assigning value, and then comparing, and then append. Assigning a value here, assigning a value, appending value, and then increment. So those are primitive operations. For example, assigning here, it is one operation, and then this is one primitive operation. This one, let's see. I mean, I will just keep it, and then this one. Those are primitive operations, right? Then returning value, return this one primitive operation. So those are those operations. For example, this comparison, it cannot be, I mean, generally it cannot be divided into mini operations. ඒ operation එකේ ඒ operation එකේ තියෙනවා ඇත්තටම අපි මේ නිකන් තව if we go to deeper level, this operation may have some sub mini operations in the processor and in memory, but generally we consider it as just one operation, primitive operation. එතනින් එහාට ඒක divide කරන්න බෑ කියලා අපි උපකල්පනය කරනවා. So we assume that it cannot be divided into smaller operations, right? So we call these type of operations primitive operations. So what we are doing here is counting primitive operations. We count these operations. How many primitive operations are there? So in this method of analysis, the running time of an algorithm is estimated without performing an experiment. We don't implement the algorithm. The analysis is performed directly on a high-level description. We don't have to implement the algorithm if we have just high-level definition. So that means if we have just, if we know the steps of the algorithm, that's enough. We don't have to implement it in the computer. We don't have to implement on the computer to execute it. If we have the description, that's enough. A primitive operation corresponds to a low-level instruction, with an execution time that is constant. So we assume for all these primitive operations, the time it takes would be the same. If we take assigning a value to a variable, the time for that, and then the performing arithmetic operation, time for that, we assume it is the same. Actually, like in real situation, it could be different. However, we assume, I mean, approximately those are equal, right? Low-level instruction, so those are equal, approximately equal. So we consider that, and then we just count the number of primitive operations. We don't care about the time. We just count the number of operations. So if we take this algorithm, for example, right? This would be 1. This would be 2, right? Like when we call this method, so those values are assigned to this, right? So one operation here, another operation here, 1, 2, and then roughly, yeah, this is roughly, right? So this should be taken as 1 or 1 or 2 maybe. Create new object and then assign the object. Let's take it as 2, 1, 2, 3, 4. So then 5, right? 6, 7, 8, and then how many repetitions? So we have to count those repetitions. And then finally added 1 here, right? So likewise we count. So suppose the count is, suppose the count is for algorithm 1, count is 10. Algorithm 2, the count is 20. Then we don't care about the time, right? Again, we count karno operations, primitive operations 10 for algorithm 1, primitive operation 20 for algorithm 2. Then actually, if we consider for one primitive operation, the time would be t. In this case, it is t. 10t, 20t, right? So in that case, the t is the same. We can forget about it. We just get the number, the counted number of primitive operations. Based on that number, we can compare algorithms. Counting primitive operations. The number of primitive operations are counted as t. Time එක විදිහට අපි ගන්නේ මේ primitive operations. The count t is used as the measure of the running time of the algorithm. The number of primitive operations an algorithm performs will be proportional to the actual running time of the algorithm. Right? Right. Right. The idea is number of primitive operations. If you take it as n, and then the time it takes for the algorithm. So these are proportion, right? So because of that, instead of t, we can use n for comparison. Total time, total time for the algorithm. Let's say it is t. අපි එතකොට හිතන්න ඕනේ මෙන්න මේ එකකට යන ටයිම් එක මෙන්න මේ එකකට යන ටයිම් එක අපි ගත්තොත් t කියලා ඔපරේෂන් එකකට එතකොට nt is like this, right? So because of that we can use n. The implicit assumption in this approach is that running times of the different primitive operations will be fairly similar. This is important. Nah? So we assume that the running time of different primitive operations are similar, approximately the same. The capture of the order of growth of an algorithm running time. So we can use this to check the order of growth. It characterizes the number of primitive operations as a function of input size A, right? So when we change the input size, so then this number of primitive operations would reflect that in the algorithm. So for example, like in this previous example here, if n is changed, so based on that the count would be different. එතකොට n කියන එක change වුණාට පස්සේ input එක වෙනස් වුණාට පස්සේ ඒක මේකෙන් reflect වෙනවා. අපි මේක count කරොත් මේ කොච්චර වාර ගණනක් මේක loop එක යනවාද, කොච්චර operations තියෙනවද මේ algorithm එකේ කියන්නේ. Right? Right. So actually today I'm not going to talk about all the, so how we compare algorithms. So we are talking about, so we talked about experimental analysis and we know why it is not suitable. And then currently we are talking about this one. And then we have our standard method mechanism. I'm not going to talk about that today. So I'm going to talk about that next week, right? So the counting primitive operations, why we go beyond that? Counting primitive operation is fine, but the thing is, the problem there is, right? So there's an, especially there's an assumption. Right? So this assumption is not totally true, right? That's one thing. And then we have to think about, I mean, even this one we have to count, even go beyond that, right? Go beyond that and check more abstract measurement, right? The counting primitive operations, sometimes it is not accurate. And based on the time that we are spending on counting, right? If it is very complicated algorithm, it would be very difficult. So what we are doing here is, so we go beyond that. We go beyond that, and we are going to find more abstract mechanism, abstract way of measuring algorithms or comparing algorithms, right? So in this case, actually, worst case analysis is important. So what is worst case analysis, right? So here you can see, like in it's basically in Avengers, I think, right? So there are, so Avengers and especially in like Marvel universe. So if you are watching movies, like there are villains, right? Like different villains, right? But finally, like in like if you haven't watched, if you have watched in like Avengers movies, like we have a worst enemy, right? So we have different enemies, right? Then we have kind of like, as it shows, right, that the worst enemy of the universe, this guy, Thanos, right? So he's coming, right? The worst case. So in when we comparing algorithms, worst case is very important. So the idea here is, if you can perform well in the worst case, then you will perform in any other case, right? I'm pretty sure you have done that. Some of you have done that in before for A-level examination, right? So if you can answer the most difficult questions, then you will answer to any questions easier than that. කියන අමාරුම ප්‍රශ්න ලියලා පුරුදු වුණොත් එහෙම ඊට වඩා ලේසි ඒවා આવුත් එහෙම කොහොමද ලියන්න පුළුවන්. worst case එකේදී හොඳට perform කරන එකන ඊට වඩා මේ ලේසි ඒවාකදී කොහොමද හොඳට perform කරන්නේ. Right? If you can survive in the worst case, you can survive in the better cases, no problem. So in even in the army or the military training, so they always, in that training, they always try to recreate the worst case. Worst case, so they train for the worst case, right? If the military, if a military person is in a jungle, he may have to survive in the worst case, like with animals, like elephants and other dangerous animals, and then without food, without water, right? In the training, they try to provide that, the worst case. So the word, even for an algorithm, it is important. So as I told you, like in algorithms, we have best cases and worst cases, right? So for example, in sorting, if array is in the worst case, right, then how it is performed. If you can check whether the array is in the worst case, how it is performed. right? Worst case එකේදී හොඳට perform කරනවා නම් එයා ඊට වඩා better cases. So if you perform, if our algorithm performs in the worst case, so then it will be performing better in any other cases. Right? The worst case එක අපි දීලා බලනවා. Input. So we can provide different inputs. Worst case input එකේදී කොහොම හැසිරෙයිද කියලා අපි check කරනවා. Right? Worst case analysis means that. Right? Worst case analysis. An algorithm may run faster on some inputs than it does on others. The reasonable way of expressing the running time of the algorithm as the function of the input size is by considering the average of all possible inputs. So usually, if we can find the average case, average input එකක් දුන්නාම මෙයා කොහොම හැසිරෙයිද කියලා අපිට බලන්න පුළුවන්. හැබැයි average case එක හොයාගන්න එක අමාරුයි. But worst case can be given. Worst case can be defined than average case. Average case එකක් කියන්නේ average input එකක් දෙන එක අමාරුයි. හැබැයි worst case එක මොකක්ද කියලා අපිට කියන්න පුළුවන්. ඒ algorithm එක අනුව what would be the worst case. So then we provide the worst case. If an algorithm performs well for the worst case input, it will always perform better for every input. Worst case එකේදී මෙන්න මේ විදිහට මෙයා හැසිරෙන්නේ. එහෙමනම් එයා ඊට වඩා හොඳට වැඩ කරයි අනිත් ඒවාට. This is a good measurement of an algorithm. Therefore, making worst case input as a standard of success for an algorithm is very practical and reasonable. So with that, we go for the next mechanism of analysis, asymptotic analysis. Today, we are not going to talk about that. So we are going to talk about big O notation and then omega notation and theta notation as well. But we are going to define big O notation and we are going to use that. Okay. So any questions up to now? Right. The third one is asymptotic analysis. Asymptotic. So remember, asymptotic analysis is more abstract, right? In primitive, it is the experiment analysis is the exact time, right? It is exact, very exact. Then counting primitive is just rough estimation, right? The asymptotic analysis is more abstract estimation. And මේ කලින් දෙකටම වඩා rough estimation එකක් තමයි මේකෙදි දෙන්නේ asymptotic analysis. But that's enough in most of our cases in our comparison. Because just looking at the algorithm, we can define this measurement, asymptotic analysis measurement. Right. Okay, so that's all for today. So any questions? Any questions from the things that we have learned? Actually, today I have just given the background, right? Our real contents are next week, so yet to be discussed. So in your any of your comparisons, you are not going to use experimental analysis, so you are not going to use counting primitive operations. No. If someone asks you to compare two algorithms, you are going to use asymptotic analysis. අරවා කරන්න යන්නේ නැහැ. අපි කෙලින්ම asymptotic analysis එක තමයි පාවිච්චි කරන්නේ. එහෙනම් මේ background එක විතරයි දුන්නේ. Real thing is coming, yet to be discussed. So next week, today I'm not going to take another 2 hours. So I'm going to stop at this point, and then we can take 2 sessions next week, the morning session before 10, and then after 10, after a break, so we can discuss another 1.5 hours, and we can finish this one, right? So I will share this note and then the previous notes and the video. Right. Any questions? If there are no questions, we can conclude the lecture.